All right, I think we'll get started now. So welcome to the second in a series of Cirrus Link webinars. Today we'll explain how to get your OT data securely and efficiently connected to cloud services to achieve a digital transformation. My name is Chris Houghton, and I'll be serving as the moderator today. With me is Arlen Nipper, President and CTO of Cirrus Link, and co-inventor of MQTT, the lightweight publish-subscribe message protocol. We also have Kurt Hokenadel, Sales and Marketing Director at Cirrus Link. And we're very pleased to have with us today Ryan D'Souza from Amazon Web Services to discuss their cloud solutions and how they provide tools to analyze IoT data. First, a little background about Cirrus Link Solutions. Founded in 2012 by Arlen and myself, we have over 70 man-years of experience in-house implementing solutions using MQTT. We are one of only 2 strategic partners to Inductive Automation who created the Ignition platform for SCADA and MES. Our MQTT modules enable the Ignition platform to connect OT data to IT services for big data analytics while providing a superior OT solution. We've developed a range of efficient and secure cloud injector modules that plug into the Ignition platform for the 4 major cloud providers: AWS, Microsoft Azure, Google Cloud Platform, and IBM Watson. In this hour, we'll provide an overview of the Cloud Injector modules, along with a brief review of our core MQTT modules, then dive into how they're easily configured to push OT data to IT cloud services. We'll then review some architectures and describe the type and volume of data we're pushing to the cloud today with real-world applications. Next, we'll have a live demo sending data to the AWS cloud before handing over to Ryan to go into some of the powerful tools AWS offers to manage and analyze your data. At the end, we'll wrap things up with a Q&A session. So if you have any questions as we go through the presentation, please post them in the chat window and we'll answer as many as possible at the end. And any questions we cannot get to, we'll follow up with you directly after the presentation. So without further delay, I'd like to hand over to Arlen Nipper to get us started with the Cirrus Link Cloud Injectors. Over to you, Arlen.
Thank you, Chris. So let me switch keyboards here. All right. So first of all, just a little bit of background. We're talking about the industrial Internet of Things and this whole world of digital transformation. And to a certain extent, it's been around 7-8 years now, and it's not happening quite as fast as I think the pundits in the industry thought that it would. And if we kind of step back and we look at the accelerated growth of the Internet of People and how that came about, and really it was all down to the fact that you had this open transport called HTTP, and then a few years after that, HTML came along, and so you had the transport, and then you had the representation of the data that was being transported. And I think we've all seen what that's done in terms of the explosion of applications and the Internet of People, and even a lot of the cloud technologies. Well, then, 11, 10, 12 years ago, the first notions of the Internet of Things came out. In other words, we had this ubiquitous connectivity, we had TCP/IP, and then everybody kind of gravitated towards using MQTT to the point where MQTT has become one of the dominant IoT transports. Then we start looking at IIoT, Industrial Internet of Things, different classification than publishing from your Raspberry Pi, but really, if you look at the security that's built in that can be implemented using MQTT, we needed a representation. We needed that HTML of the Internet of People, and that is the Spark-Plug-B specification. So if we take those as we move forward, that gives us the ability to put together MQTT-based architectures where we can represent the data and discover it automatically. So if we look at the components that we've got, here we've got an Ignition gateway, we've got Ignition Edge, and then we've got these notions of MQTT clients and an MQTT server, and those products that we have developed to plug into those platforms. So MQTT Engine gives us a client that understands Spark-Plug-B messages. Transmission can publish those in Sparkplug. And then we've got tools like Distributor that let you put an MQTT server right on your Ignition gateway. Now, what we're talking about is bridging the gap for digital transformation. And this isn't just for customers, this is across the board. This is for OEM suppliers, customers, service providers. Everybody is looking about how do we go about providing tools for digital transformation, or how do we consume those tools so that we as a company can accomplish digital transformation. So at first level, it's at C level saying, we've got to get our products to embrace IoT. It's the customers who the digital transformation officer says, we've got to start taking advantage of this for cost reduction. It's the competitions being able to offer solutions that are interoperable, driving the cost down, and of course, leveraging big data, but doing that properly. And then the continued problems with bridging the OT-IT gap is what you're doing cost effective? It can't have custom code. We all know that coding on operating systems is not scalable, so we've got to look at what tools are available. And then the scalability of your solution as you go. I can still remember when we first started working with inductive automation, we thought systems with 50,000 tags were huge. Now we're talking to customers with 2 to 5 million tags. So is that solution going to scale at that level? And we've got to make sure that it uses open standards. It can't be proprietary, getting you into a siloed situation where you can't migrate out. Now, so the reality is that I think all 4 cloud providers are doing a fantastic job in giving us tools to manage data on the cloud. So the executives get the presentation, and we've got all of this predictive analytics and machine learning, artificial intelligence and data lakes and connectivity to other services, and everything is great. And then we've got this little line down to OT data. And that's really not their fault. It's not their fault that a 20-year-old Modicon PLC won't interface to the cloud. But that's the reality. So the proposition is we've got all this possibility, but the reality is that getting the OT data and not disrupting an operational system at the same time is crucial. That's the first step. And once that infrastructure is in place properly, then being able to provide that information to the wealth of services that cloud providers have. So we've tried to make it simple. We're going back to this notion of a single source of truth. And by what we mean there is that, again, we've had 40 years or more of dealing with register value pairs. So we've got Modbus register 40,012. It's a value of 520. What is that? Is that a pressure? Is it a raw analog value? Has it already been scaled? What's the engineering units? What's engineering high, engineering low? So we double click on that tag and we edit it and we give it context. And if we've got 50,000 tags, we're double clicking on 50,000 tags or 1,000,000 tags. So one of the things that we do with Sparkplug is being able to standardize tags to where a tag can represent or have a tag name per your system, a timestamp that stays with that tag, the real value of that engineering units or that process variable, what are the engineering units in the range, and what's the data type. We make it quick and simple to configure things with tools, not coding on operating systems, but have a proper tag browser and the tools that you would, as a SCADA or operational engineer, think that you should have available. It's got to be cost effective. Now, we've talked about in the previous webinar, we talked about getting data effectively from the field into a Ignition gateway. But cost efficiency also comes into play when we're talking about connecting to the cloud. Because every time we publish a piece of information, it is just micro cents. But if you're doing that for millions and millions of tags, then you need to be very efficient, only send data when it changes. And then we can go through the fact that if you have a value that is 12, you don't need to publish it every 1 second to know that, because with MQTT we have state, so therefore you know the value at any point in time. And is that scalable? Now, the topologies we're going to be talking about, again, now that we've got the tags from our operational data in the field into an Ignition gateway, then what are the components that you can plug into Ignition to get that into the cloud services or some of the newer edge technology like Amazon Greengrass? And with that, we're talking about our cloud injectors, AWS, Google Cloud Platform, IBM, and Microsoft Azure, as well as MQTT transmission, being able to directly connect to the MQTT server that is natively comes with every Greengrass, every Amazon Greengrass instance. Now with the AWS Injector, once you've got the tags in your Ignition gateway, you can connect to Amazon Kinesis, both Streams and Firehose, as well as DynamoDB. From there, you have Lambdas that can take that to any of these services within Amazon. Uniquely, our transmission module knows how to connect to the MQTT server in Greengrass so that now, if we're doing machine inference modeling right on the edge, we can get real-time information directly into Greengrass core. For Azure, we can go into Azure IoT Hub or Azure Event Hub with any tags that we've got in our system. The same with Google Cloud Platform, and again, with IBM Watson. Now, once we've kind of discussed all of this tooling and everything, it would be good to go through how can we use that going forward. So what I'm going to do is I'm going to turn it over to Kurt, and he's going to go through some actual use cases that we've done with existing customers. So Kurt, I'm going to give you the keyboard, and it should be good. So over to you, Kurt.
Thanks, Arlen. So as we've been doing this for the past couple of years, we've really run into two different, I'd say, solution scenarios on how this is implemented for different applications. The first one I'll talk about is the edge. And what this means is basically you have the endpoint where the process data is at, and you're doing direct connectivity to the cloud operations. For this, and looking at the first image here, this doesn't necessarily need MQTT, so any existing factory floor implementation of Ignition, any SCADA application, it could be oil and gas, it could be wastewater or not. All that's required is to install the cloud module, and you have connectivity to the cloud applications. And so if you have an Ignition system with 1 million tags or 50,000 tags, any application, this is pretty much the direct contact from the factory floor or the SCADA system to the cloud, and that's one solution. The next solution that we see in implementing this is where there's an existing SCADA system that's not Ignition. The nice thing about the Ignition platform itself, it has an OPC UA server or OPC HA or DA that can connect to existing SCADA systems. And so all you need to do here from a cost-efficient standpoint, again, is you just get the one cloud injector. The platform comes with it, I think, and you have to get the OPC UA server client. But those two components is all that's required to take an existing SCADA system that's already in place at a factory floor or any application, and you can connect to that data, provide the context that Arlen was talking about using the asset framework that's provided within Ignition to tag name and put the engineering values and the scalability all within those tags, and then you can take that and easily connect to the cloud services. The other situation that we see a lot of is just connecting to OPC UA servers like Kepware, Matricon, Autosol. The same thing applies. It's just a very cost-effective solution with all the tools. You just get the cloud module that you need on the platform, and that's all you need to get, and you start connecting those solutions to those cloud platforms. And the last is where maybe you have some like an Oppo 22 with Ignition Edge, where there's some IO, remote IO, and all I do is, they just want to connect this one side up. You can actually plug in one of those cloud injector modules on that solution and take that information from those PLCs and RTUs direct to the cloud. And I'd say this is more of point type solutions. This is where we have customers with a few sites and not very many sites, but they just want to start taking advantage of it. The second solution that we see a lot more of is in, I would say, hub and spoke architectures. And this is where we have customers that have, many plants across different regions, different areas of countries. It could be some in Asia, some in North America. And they have either multiple factories or they have lots of endpoint or asset management devices. And so in this scenario, we install an MQTT infrastructure. So like we have one customer that has 65 plants in North America. And so at each plant facility, they put in MQTT to take advantage of the MQTT connectivity into a central ignition system that then goes to the cloud services. This is also the case for connecting the same OPC-UA in existing SCADA applications, as well as if you're looking at edge devices. So in this scenario, the benefits that you get is, when you're using MQTT, each of the transmission modules at the remote edge facilities or factories have store and forward capabilities built in. So if there's a failure within the system, the data is stored so you don't lose any data. The efficiency of it is you're only sending change data up to the MQTT central ignition system. So then only change data also is only going to the cloud platform system. So to give you an example of, the kind of capabilities that this has, one of our customers at each of these facilities on, I think the 65 plants they have 200,000 tags, of which 40 to 60% are changing every second. And so they have store and forward built up. Even if you have a failure within the system, all those tags are coming in with all the proper context and information. They go into the central ignition system, and they're using AWS. That goes into AWS and provides the solution. So then you have, I would say, a typical oil and gas scenario or wastewater management where you have a lot of endpoint node applications, a lot of pump sites or remote sites where you take advantage of Ignition Edge using MQTT, taking that same information in, getting the data transformed into usable data that goes into the ignition system again. So all this is, cost effective, simple to implement, and easy to install. And with that, I will give it back to Arlen.
All right. Thank you, Kurt. So what we're going to do is we're going to do a live demo. What I have to do is throw up the demo topology. So what we've got here in our office in Kansas City, we've got pretty much all of these devices that are connected in. We've got 2 Chariot MQTT servers are running up on Amazon EC2 instances. We have a distributor MQTT server running on our Ignition platform. So that gives us 3 levels of redundancy at the MQTT connectivity level. Then we've got an Ignition platform running on another instance of the Amazon EC2 instance. And then what we're going to show is connecting using the AWS Injector into Kinesis Firehose. Now, again, as I mentioned before, we can go into Kinesis Streams as well as into DynamoDB, but because Firehose gives us direct connectivity to S3 buckets, that's the easiest one to demo in this case. So we'll get out of the presentation. And the first thing we'll do is we'll take a look at our Ignition Gateway and just see what's on it, how it's configured. So if I look at this right now, we already have 58,000 tags coming into the system. Now, again, if you would have watched the previous webinar, we'd have shown that we discovered all 58,000 of those tags in less than 10 seconds, and with all of their proper metadata that we've been talking about. Now, if we look at the configuration, we're going to see that in the modules that we've got installed, we've got all the standard Ignition modules, and then down here we've got some of the Cirrus Link solution modules installed. So all of our Injector modules. So we'll go through the settings of some of the Injector modules. So here's Azure Injector, and as I mentioned before, with Azure we can go into IoT Hub or Event Hub. So with IoT Hub, you simply set up your device in Azure, you come in, you plug in your security certificates and your authentication, and now you would have a direct connection into Azure IoT Hub. For Google Cloud Platform, it's very much the same. So if I look at Google Injector, my IoT core, from there I can edit that, set up my endpoint, set up my security, and I would have a direct connection into Google Cloud Platform. And then IBM, and being able to directly connect into the MQTT server running on IBM Cloud, and the ability to set up all the certificates and security on that as well. But what we're going to be demoing today is the the AWS IoT connector. So let's go into our AWS Injector. And from here, we can set up Kinesis or DynamoDB. And so we're going to set up Kinesis. Now, before we get into this, we'll open up the editor here. We'll take a look at the other side of this connection. So now we're going to go in, and this is the consoles that I'm going to be working with on Amazon. So here we've got Amazon Kinesis, and from here we can create a delivery stream. Now that's where you would create your new endpoint, and that's where you set up your IAM certification or authentication for only allowing applications that you want to be able to connect to this data. So what we've got is a demo Firehose stream. You can see here's my IAM role, and from this I can see that I'm going to go process, when data comes in, I'm going to process it with this Lambda, the Firehose demo records, and I'm going to take it to an S3 bucket. So if I look at my Lambda, the Lambda is a very simple Lambda that's basically going to take every message that comes off of this Firehose connection, and it's going to print that out to my CloudWatch console so I can have some debugging, so we can see data arriving. And then here on our S3 buckets, we can see that this is where those data that we're publishing is going to go into a bucket by the year, month, day, and hour that we're seeing here. So we've got our endpoint set up. It's called process, we've got our demo Firehose stream set up. So now what we would do is go into our Ignition instance, and this is our injector settings. And this is where we put in the AWS access key, the secret key. We could use session tokens if we wanted to as well. And then we go down, and basically now we've enabled a connection from our Ignition gateway into Amazon. Now, if we look in the general settings here, we'll notice that we haven't enabled it yet. So the last thing we want to do is we want to go to our Ignition project and look at all this data that we've got available to us. So we've got 58,000 tags. We've got 1,427 devices. And if we look here, we've got one device that's connected in. It's running Ignition Edge. It's connected to a Modbus PLC, a Click Modbus PLC, and then two other PLCs that we were kind of interested in that data. So how quickly could we take that information and get that published up to Amazon? So let's go back into our configuration for our injector module. And we're going to do a tag agent. And in the tag agent, we're going to tell it that we want to get all the tags that are setting in the Edge Nodes IA Group Ignition Edge folder. And we want and we have a tag pacing period. And what we talked about before from an efficiency standpoint is that we want to be very efficient in the way that we package data up and publish or push it up into Kinesis Firehose. We don't want to do it on individual tags because that would create a huge number of messages. And remember, we're having to pay for each message. So I've set it initially here for a tag pacing period of 2 seconds, and we'll see what that looks like when we get some data going in. So now what we're going to do is let's go in, and in our Ignition tag browser, we also bring out some metrics of our Amazon connector. So we have an AWS Injector Kinesis settings here, and you see that I'm not connected yet. They haven't pushed any data. So the first thing that we're going to do, and also I want to point out here that we don't have any real-time data. There's none of this data is changing, so that we can see that initial birth certificate into Amazon. So we're going to go into our console, go into our general, and basically we're going to plug in. So we've set up Kinesis on the cloud, we set up our injector, so now we want to plug it in. Okay, and now you can see we've published some messages. We've published 5 messages. So we should be able to see those up on our CloudWatch dashboard. So we'll go into CloudWatch, go into our process stream. Now it's going to take a while. The logging into CloudWatch isn't real time, so it'll take a while. And what we're going to do is we're going to look at the messages that arrived when we first connected, so that we can tell Amazon, for the data scientists or anybody wanting that data, we can tell them what was on that ignition gateway. Yeah, this will show up here in a little bit. So then what we're going to do after we see that initial publishes is we're going to go in and we're going to turn on these 2 Modbus PLCs. We're going to start injecting data in at a 1-second rate. And then we're going to see that it only publishes the data that changes, but we'll see up in Amazon that we also got things like the fact that this tank 115 had engineering units. It's 0 to 30 and it's in feet. I can tell you even, what's in that tank. So we'll be able to do that, and then we'll be able to see these real-time process variables show up as well. So let's go back to our CloudWatch. There we go. So now we've got a stream of data we can take a look at. And you can see here that what we've got is, pull this over, we got some births. And so if we look at the Click Modbus PLC, you'll notice that we got a very well-defined JSON payload that's telling us that we have motor temperature and what its current value is. We have RPM. We can look here and what the engineering high, the engineering units, engineering low, and its current value. And all of these tags, each tag that we've got defined. So here's our tank 115. We can see that it's got Boulevard IPA in it. We can see that it's 0 to 30 and the engineering units are in feet. So now we know all of these tags and what's going to be published to us continuing on this session. So now we'll close this for each of those devices we learned. And now let's start pushing data in. So let's go back to our dashboard. And notice here, we're still looking at the fact that we've only published 5 messages, but we're connected. So we'll go into a Node-RED flow, and we'll start injecting values every 1 second. And deploy. So now we should see that for these devices down here, now we've got data changing once a second. And if we go up and look at our Kinesis, the Kinesis bytes, you'll see that every 2 seconds, remember I said we had a tag pacing period of 2 seconds. Every 2 seconds, we're publishing any tag that changed with its UTC millisecond timestamp so that you know exactly when that data was acquired in the field at the edge device. So we'll go back to our dashboard, refresh this. Again, this will take a while. And then what we'll see is that every one of these messages that are coming in off of Kinesis Firehose are also going into your S3 buckets. And these buckets are created once every 5 minutes. So again, this isn't built for, from a real-time demo standpoint. We know, working with all of our customers, that indeed all this data does go into buckets when it's supposed to. So we'll go back to CloudWatch, refresh it one more time. And then finally, what we're going to do is, while we're waiting for that to refresh, the other thing that you might have noted when I changed the publish period here, and I'll do it again, is that, remember we talked about the fact that since we're using Sparkplug, we have state. And so if you notice, when I change the publish period here, I'll turn them all off again. Okay, so we're going to turn off our IO. And you'll notice when I did that, all these tags went stale. They're all red. Well, what that resulted in is we published a message up to Kinesis that said that all those tags went stale. So that's how we have state. Even though we're decoupled from the standpoint we may only be publishing once every 2 seconds or once every 10 seconds, we know exactly if that process variable went offline, and we know the timestamp of when it did. So that lets us, that's one of the enablers, if you will, of being able to publish data on exception, but still know that you've got your truth of your data. So here, refresh this. And now we have a lot of messages, and you'll see that we're only publishing the data that changed. We're not publishing all of the Modbus values, but you'll see here that we have multiple dimension X's, and they've got different timestamp values. If we go to the next message, you can see that we have multiple flow rates and multiple pressures, but those were sampled over that 2-second tag pacing period that we had. So we're efficiently using the Kinesis messages, but we're still getting all of the information up to the cloud. So I hope what you saw was very, very quickly, I said, oh, I want to get data from these devices that I already have going into my Ignition Gateway. I set up Kinesis. I pointed our injector at that, and in just a few minutes, I had data flowing into Amazon. So what we're going to do is go back into the presentation, and I'm going to turn it over to Ryan, and Ryan's going to tell us how can we take advantage of all this data now that we've got it in all these S3 buckets up there. So Ryan, I'm going to give you keyboard control, and you should be good to go.
Okay, great. Thank you, Alan. This is Ryan D'Souza, and I'm an AWS IoT solution architect. And I'd like to start with this really simple question. If you knew the state of everything and you could reason on top of that data, then what problems would you solve? And at AWS, it is our mission to provide customers with a digital platform and a set of tools to securely connect to devices, to securely ingest the data, and then use analytic tools to process that data and analyze that data so that you can solve real business problems that deliver business value to your organization.
Wait, there you go.
Okay, cool. So now let's take a look at some of the enabling technologies that is driving business transformation and digital transformation in industrials. So first of all, you have the computational power that the cloud offers in order to process industrial data at scale. You have edge technologies like Ignition Edge and AWS IoT Greengrass that we'll be talking about in order to better manage industrial data at the edge. You've got robotic services to automate industrial processes, additive manufacturing, which is also called 3D printing, which provides more flexibility and efficiency to manufacturing operations. You've got 5G networks, which is going to enable a whole new set of industrial applications and use cases. A lot of customers are now creating a digital representation of every physical asset using digital twin technology. You've got advanced analytics and machine learning in order to build predictive models. And finally, new ways to interact with manufacturing systems using augmented reality and virtual reality. So let's take a look at Industry 4.0 in the context of the cloud. So Industry 4.0 is the fourth industrial revolution. It's really the marriage between physical systems and digital systems. It is the next phase of digitization in industry, and it is disrupting and redefining industry. Some of the most common Industry 4.0 use cases include improving operational efficiencies, reducing cost, reducing unplanned downtime, improving product quality, asset performance monitoring, predictive maintenance, and optimizing operations. So as we jump into taking a look at a couple of architectures, I'd first like to walk you through some of the architecture objectives and considerations. The first being low latency. There are some industrial applications that need a low latency response where you need to process the data at the edge and you need to take action at the edge. In other words, the round trip to the cloud is too long. An example of an application like that is vibration monitoring, where you need to take quick action at the edge by processing the vibration data at the edge. The way we do that at AWS is using the AWS IoT Greengrass service and platform. In industrials, you'll find a mix of both brownfield and greenfield protocols. So a number of various industrial protocols from MQTT to Sparkplug, Modbus, Modbus TCP, Profibus, Ethernet IP, and the list goes on and on. You need to have a platform like Ignition and like AWS that can support these various industrial protocols. What happens if the network goes down? If that happens, you need to be able to operate independent of the cloud. So the architecture needs to have the ability to process data locally and take local actions. And we enable that with Ignition and with AWS IoT Greengrass. Customers start with a single use case at a single site. But what happens when you want to add use cases to the platform? What happens when you want to add additional sites and support multiple sites and multiple use cases? You need to have a platform like Ignition and like AWS that can enable you scale and enable you grow. Security is super important. You need to have security at the edge. You need to have security at the network layer, and you need to have security in the cloud. You need to limit the number of ports that are exposed and open to the internet. And using AWS IoT Greengrass and Ignition, we're able to provide you a secure solution. You need to have the ability to support different alerting mechanisms, both at the edge and in the cloud. And finally, once the data lands in AWS, there may be different users of that data. There may be data scientists that need the data. Maybe an OEM company needs the data to build machine learning models. So how do you securely provide access to the industrial data that you've collected to different users that need them to build industrial solutions? So first, let's take a look at the edge architecture. So what we have here is the Ignition Edge platform collecting data from industrial facilities, which is operational data or OT data. That data can be sent either directly into Kinesis on AWS, or it can be sent via MQTT to AWS IoT Greengrass to be processed locally at the edge. And that data, once it's processed, you can then send it into AWS IoT in the cloud. With Ignition Edge, you're able to do better tag management at the edge. You're able to add context to the data, all this done through configuration with no need for coding. This provides you with a single source of truth of industrial data, which greatly accelerates and simplifies the ability to build applications and machine learning models in the cloud. So now let's take a look at the edge architecture from the lens of ISA 95 and ISA 99. So this is a very typical edge architecture where you have industrial equipment connected to PLCs. It may be a Siemens PLC or a Schneider PLC or an Allen Bradley PLC. So you need to have the ability to support multiple industrial protocols. You need to have the ability to process that data at the edge and do protocol conversion at the edge. You can have Ignition Edge combined with Greengrass running on a single gateway that does the protocol conversion, that does the tag management at scale. You can add context to the data at the edge. And then finally, you can send that data using the MQTT channel into AWS IoT on AWS, or you can use AWS IoT site-wise to ingest OPC UA data in AWS. So now let's take a look at the cloud architecture. So this data is collected from Ignition at the edge. It is then sent into Greengrass as an example. Using AWS IoT Greengrass, you can filter that data and process that data locally. You can send that data into AWS IoT Core, which ingests MQTT data. If you need to do threshold monitoring and send off an alert, you can use our simple notification service to send email and SMS alerts to users. You may need to process that data in flight or in real time, and you can use Kinesis to do streaming analytics of this data to detect anomalies. You can use Athena to query that data and QuickSight to visualize those anomalies and the industrial data. You can even start building an industrial data lake using Firehose and Amazon S3 as the data lake and archive that data using Glacier. You can also process that data using AWS IoT Analytics by creating data pipelines and processing pipelines. You can use Jupyter notebooks to author machine learning models. You can build and train those machine learning models using SageMaker. And finally, you can deploy those models to run at the edge using Greengrass machine learning inference. So what a lot of customers are doing today is using AWS IoT Core to ingest MQTT data at scale, using AWS IoT Analytics to process that data using pipelines. You can then use SageMaker to build and train machine learning models. And you can finally run those models at the edge using AWS IoT Greengrass ML inference capability. So I'm going to wrap up with this view of AWS IoT platform for industrial applications. You can see we've got Ignition Edge, which can process the incoming data and manage tags at scale. You can add context to the data and create a single view of the data. You can use AWS IoT site-wise to build asset models and industrial models in the cloud. You can use AWS IoT Greengrass to process that data locally and run edge analytics. You can use AWS IoT Core to ingest the data securely into AWS. You need to manage your IoT devices at scale, and you can use AWS IoT Device Management to manage your lifecycle of IoT devices. AWS IoT Defender keeps your devices secure and does anomaly detection of devices related to security. You can use AWS IoT Things Graph to build workflows and applications in the cloud. AWS IoT Events is a complex event processor for complex event detection. And finally, AWS IoT Analytics to finally get analytics on the data and build batch analytics and machine learning models. With that, let me send it over to you, Chris.
Thank you very much, Ryan, and thank you guys. That's a great presentation. I think Alan's going to give me back the screen here momentarily. Whilst we're doing that, if you haven't noticed already, in your control panel, you should have a handout, which we'd encourage you to download, just giving you a little bit of information about the architecture and some information on contacting us. So please feel free to download that handout to give you some information to take away. Now, we've had a lot of great questions come in during the webinar, and I'm going to pick out a few here to answer. And as I said, we'll follow up with any we don't get to. But Alan, I think this first one is for you. Is there a way to limit the bandwidth used to connect to the cloud for remote areas where cellular data is the only option?
Well, that's kind of why MQTT was invented. I think people have probably already heard me say this, but you know, MQTT was invented 1999 to get better information, more information over a system that Phillips 66 had. So they had VSAT connectivity. They had an aggregate of about 300 baud. That's 300 as in 300. And the ability, again, what you have to understand is reducing bandwidth. One of the ways that you do that is you have state, because if I have a pressure and it's 300 and I publish that one time and MQTT is going to guarantee that I'm going to get it to my applications, I don't have to publish it again unless it changes. Now, but you can only do that if you have state. And state tells me that it's out there and nope, that pressure's still 300. So we use a combination of, you know, what are you monitoring? How often do you want to look at it? Do you want to put dead bands around it? And I think what we've proven time and time again over the last 20 years using MQTT is I can say unequivocally that if we replace a polling protocol with MQTT for the same data at the same arrival rate, we have an 80 to 95% bandwidth reduction. So, you know, again, now you could say, you know, at the end of the day, it becomes physics, right? If you've got so much data, you're not going to get it over that cellular network. But I think by optimizing it, using tools that you have on Ignition Edge, knowing how your infrastructure is built out, knowing the process variables, I think you can do a huge amount of reduction in the bandwidth usage. Now, conversely, if you can reduce it by 90%, maybe that's 45% more data that you're currently leaving stranded in the field that now you could afford to bring in.
That's great. Thanks, Alan. Here's another one. Kurt, maybe you could take this one. How do you connect PLCs with your platform using BACnet to control devices such as light switches and send this data to the cloud?
So this is kind of a new thing. So here, I think in one quarter, there'll be a release on the Inductive automation platform to support BACnet. So that'll become a common protocol on it as a driver to connect to those devices. So as if you're going to building management systems and things of that nature, here within a quarter, you'll actually have the tools within Ignition to utilize that natively, and then connect the data into Ignition, and then use all the tools from there to connect into, you know, MQTT or, you know, the different cloud platforms, just as the tools we showed here today.
So would you actually send that data straight from the edge device straight to the cloud, do you think, Kurt?
Typically, you know, it depends if it's one plant system. If, like I said, if they have a hub and spoke scenario where they have multiple systems, BACnet systems across many facilities, which a lot of these service applications are doing, they would, most likely put in an MQTT system that then centralize that data into a central gateway and then concentrate it to go then to the cloud platforms from there as the most efficient usage of connectivity.
Okay, great, thank you. What success stories can we talk about and where the technology has been used? Can you take that one, Alan?
Unfortunately, most of our, as everybody knows in this industry, it seems like everybody wants an NDA. Everything that I showed you and the architectures that Ryan went through, the architectures that Kurt went through, those are all as a result of actual customer engagements. So we do have customers publishing 200,000 tags with 40, 50, 60% of those changing every second. We have multiples of those going into AWS through the Kinesis Firehose. We have in the architecture that Ryan went through, that literally was one of the use cases, is that, remember the single source of truth, in that one of the big problems with machine learning, especially on Greengrass, is that you publish the data into SageMaker to learn it, to build your model, and then you deploy a Lambda that's the machine inference. But if you don't have a single tag naming convention, then you're changing code. And I think everybody on this call can imagine, what if you sent a technician out to, you got a plant in China, you got a plant in South America, and a plant in America, and you're telling them to change Python code. That would be a no-starter. But by what I showed you today, when we looked at those messages that we were publishing into Amazon, it had a common tag name. So we knew what device it came from, all the way down to the tag name, so that when we build our machine learning inference model, now Greengrass can subscribe to that same topic namespace. So now you've reduced the complexity, because you can say, all of my tags are going to use this namespace that's defined by Sparkplug, and now it doesn't matter where in AWS you're using that, you can use that namespace architecture to bring that back in. So we've had a lot of successes. Hopefully, as people can see with the infrastructure that we were demoing here today, all of those were a result of actual customer engagements.
That's great, thanks, Alan. Last one I think we'll do today, and this one will be for you, Ryan. How do I work with AWS to develop a cloud ML predictive analytics solution?
Yeah, that's a great question. And so a couple of different ways. We've got some very qualified partners in this space that can help with solution building and can help accelerate solution development. In addition to that, at the AWS website, we have written up a number of blog posts as well as quick start guides. This can help customers quickly get started and provides step-by-step instructions on how to build a solution. And finally, if you need help in any of these areas or need help finding the right partner or the right quick start guide, feel free to contact me. You'll find my contact information in the presentation.
Great, thanks very much, Ryan. And thank you very much, guys, for a great presentation. Thank you very much for all the attendees for your time today. You see contact information on the screen. It's in our handout. If you have any questions, absolutely give us a call or give us an email. We'd be delighted to follow up with you directly. And thank you again for your time.